is the concept of pipelining. By the way, you must have heard the terminology called concurrent engineering. There is something called concurrent engineering. You know, like small companies versus big companies. You cannot, sometimes for small companies, they employ concurrent engineering, like engineers who can do everything. You know, an engineer who knows analog, who knows digital, you know, and he knows so many things at the same time. There could be a company made of 5 people, 2 of them are engineers, and 1 accountant, and 1 secretary, and 1 boss, for example. Then these 2 engineers need to be experts in too many things. They need to know too many things. That's called concurrent engineering. But that's not the situation for big companies when you have very deep specialization. For example, in mixed signal companies, even here in Southern California, like Raytheon, for example, like JPL, like uh, many other many mixed signal companies here in Southern California, they have deep specialization. Like you have 1 engineer dedicated for designing analog to digital converters. There is 1 engineer dedicated for designing D to A converters. 1 engineer dedicated for designing band gap reference voltages. So, and it's not only 1 engineer. You could have a group for band gap reference voltages, a group for high speed A to D conversion, a group of for analog front end, things like that. And you could have 100 engineers in the company, for example, if in big companies. So there is no need for concurrent engineering here because you can have deep specialization. But the whole idea is the difference between the 2 kinds of companies is the degree of parallelism among the different jobs undertaken by each and every engineer. The concept of pipelining, here is the difference between non-pipelined and pipelined architecture. For non-pipelined architecture, you do fetching and then execution. So let's say we have instructions in series. You fetch number 1, you execute number 1, you fetch number 2, execute number 2, etc., etc. So you do only one thing at a time. But whereas in pipelining, you do fetching and execution simultaneously. So while you are executing instruction number 1, you're fetching instruction number 2, and while you're executing instruction number 2, you're fetching instruction number 3. So by the end of the day, you will discover that you have done more things here. By the end of this number of clock cycles, we've executed 5 instructions here, whereas here we executed only 3. There is, of course, an overhead for pipelining because the very first time the instruction is fetched, that time is wasted all the time. You know, you cannot overlap it with anything else because this is the very beginning. And the last one also cannot be overlapped with anything else. So there is always a penalty for filling the pipe and for emptying the pipe. That's what it's like a pipe of water. And if you have a pipe of water, let's say at home or in a backyard, for example, the water takes like 30 seconds from the beginning till it reaches the end. So it needs 30 seconds to fill the pipe. that is an overhead because it's a wasted amount of time. You cannot improve over that situation. But when the 60 minutes, the 60 seconds elapse, there is going to be a continuous flow of water. Each and every gallon of water poured at the inlet is going to appear at the outlet instantaneously. So there is no waste of time at all as soon as the overhead period has elapsed. That's a very famous concept, and there is a class of pipelined A to D converters if you need to know more information. I have actually a couple of papers on pipelined A to D converters. You can go to the literature and say pipelined A to D converter, WAGD, and here you go. You're going to see something there. All right, so let's now go to jump to subroutine and call instructions, I think. Yeah, we've talked about that already. Using index registers, index addressing mode, you're going to see something about indexed addressing in the final exam. By the way, I placed some material. I got a couple of questions before the lecture. Somebody was asking, how are we going to turn in the homework? And I think I answered that question a few days ago already by putting something on the web. I told you that you're going to submit homeworks in two batches. The first three homeworks are going to be in batch number 1, and the last two homeworks are going to be in batch number 2. And I already gave you format for submitting homeworks. You're going to give the course number. You're going to give the name of the file, like homework 123, HW123, something like that. And then you're going to put your last name, and you have to have a PDF file. So you're going to say PDF. And please follow these formats. It's going to help me a lot when you follow the format. Please don't invent your own format. Just follow the format that I gave you to submit the homework. And we're going to have a similar story for the final exam. You need to submit the final exam to me on the day of the final exam in the same way. You're going to have to do the same thing on the day of the final exam. And so using index registers, you can load X with some number, clear accumulator A, and store A in some number in location 800. Suppose we want to store that number in different locations. 801, 802, 803. The question is, how are we going to sequence through these instructions? How are we going to increment? Well, use an index register. That's all. The index register X will carry some number, some base number, and then you're going to add 0 to it. You could add 1 to it. You could add 2 to it. You could add 3 to it. You know, so you could increment X each time here. Increment X, you know.
So is 0 the offset value or X?
The offset value actually should be the 0.
Okay.
The offset value is the same. In this particular example, we have
Right.
the same offset value, but we keep incrementing x. In some other applications, we keep x fixed, and we keep incrementing the offset value.
Okay.
Yeah. So both are there. The loop version of the program clearing 50 RAM locations starting at address 800 hex. You're gonna see a problem like this on the final exam, by the way. I'm gonna ask you something like you're having like there are 20 memory locations. They need to be mapped into some other area. Take these 20 locations and move them to somewhere else. Copy them somewhere else.